Hey guys, welcome back. In this lesson, we'll look at how to perform regular join operations in Hive. Join operations like inner join, left and right outer joins. We'll also look at how we can perform join using inequality conditions. We'll also cover a new join called left semi-join, and finally we'll end the lesson by looking at the number of map-reduced jobs needed to execute our join instructions. So to perform joins, we need more than one table. We already have one table, which is our stocks table, and we also know the structure of our stocks table. Let's look at another data set, which is the dividends data set, and we will also look at its structure. And we'll use this data set as a second data set to demonstrate the joins. Whenever a stock gives away dividends, it gets recorded in the dividends data set. The dividends data set, as you see on the screen, is a text formatted file with line-by-line records. Each record or line in the dataset will have the symbol name, the date when the dividend was issued, and the actual dividend amount. It is also a comma delimited file. With that information, let's create a table. As you can already see, the common columns between the stocks and the dividends table are exchange, symbol, and year, month, date. The dataset is already loaded in HDFS and it is in location user Hive input dividends. So I'm creating a dividends table as an external table pointing to that location. So let's go ahead and create this table. Let's now do a simple select listing about 100 records from the table, just to make sure our table is created properly. There you go. So the dividends dataset is now ready to use. Now that we have two tables to join, let's look at some join queries. If you are familiar with traditional SQL, these queries will look very familiar to you. They are no different at all. So let's first start with the classic inner join. Let's join both the data sets, that is the stocks and the dividends data set, on symbol and year, month, date. This will result in records from the stocks data set which were issued a dividend on any given day. Let's execute the query. This join instruction will be translated into MapReduce job and we'll see the output. There you go, that is our result set, and we have about 1600 records in our result set. Let's go ahead and look at the left outer join. This left outer join query will bring all the records from the stocks table with matching records from the dividends table. If there is no match, null will be substituted for columns from the dividends table. So let's execute this query. So the output is being printed now, and as you can see, if there is a match on the dividend side, you will see the dividends records on your right hand side, but if there is no match, null values will be substituted for the dividend columns in the query. And this is going to list the entire stocks dataset because you're doing a left outer join. And we don't want to print the entire stocks dataset on screen, so I'm just going to kill the output. There you go. Next query is a slight variation of the left outer join query. Here we have added a where clause to filter out the dividend records which does not have null values. This will result in the same output as the inner join query. Next in our list is right outer join. This query will display all the records from the dividends table with matching records from the stocks. If there is a match, or null will be substituted for columns from the stocks table when there is no match. So that's a classic right outer join query. The next comes the full outer join, which is a combination of both left and right outer join. This will display all records from stocks and dividends table, with corresponding values from both tables if there is a match. If there is no match, null will be substituted in columns from the appropriate tables. Next, let's look at left semi-join. It is an interesting join and a good interview question. So listen carefully. But before we look at the left semi-join query, take a look at this left outer join, for instance, between stocks and dividends. Let's say row number 1 from stocks has a matching record in the dividends table in the very first row from dividends table. Still, row number 1 from stocks will be attempted to match with row number 2, row number 3, and row number 4, and so on from the dividends dataset. But sometimes all you want to know is whether the record from the left-hand side table is present in the right-hand side table for a given matching condition. That is all. As soon as there is a match, you want to move on to the next record from the left-hand side table. This will be more optimized than a traditional left outer join query. This is exactly what left semi-join does. And the operation is very similar to in or exist clause that we are used to in regular SQL. Older versions of Hive did not support in or exist clause, but Hive version 0.13 and above supports them. So in older versions of Hive, left semi-join was used as a substitute for the in clause. So that is a left semi-join. And the syntax is very simple. Just replace your left outer join with left semi-join in your query. That is it. So far we have looked at joins that is based on equality conditions in the on clause. But let's try this join query with inequality condition like this. We're saying join stocks table with dividends table when the date from stocks is greater than the date from dividend. In traditional SQL, this is a valid join, but let's execute this join in our cluster. As you can see, we will get an error. The reason being inequality joins are not supported in Hive because it is difficult to express inequality joins in MapReduce. So here is a question for you. How do you write a join query with an inequality condition? Take a look at this highlighted query. What you can do is you can do a cross join and then apply a where condition like this. The cross join will result in a Cartesian product between the data sets. So on the result set, you will apply the inequality condition to get the desired output. But cross is an expensive operation because it does a cross product between two tables. So unless you absolutely need to do it, do not do a cross. Okay, moving on. So far, the examples we looked at involve only joining two tables. But how about joining more than two tables? Joining more than two tables is not a problem with Hive. Take a look at the highlighted join queries, and both are perfectly valid join queries. There are three tables involved in each join query. So writing a join Hive query with more than two tables is not a problem. But I have another great interview question. If the interviewer would like to assess whether you know how internally a MapReduce job will be structured behind a Hive join, he or she would most likely ask this question in an interview. How many MapReduce jobs do you think will be needed to perform each of the highlighted join queries? The answer is, if for every table, as long as the same column is used in the join clause between the tables, then Hive can do the join in the single MapReduce job. Look at the first query. Table B is mentioned in both the join conditions, and in both the join conditions, column key 1 from table B is used in the joins. So the entire join operation will be done in one MapReduce job. Now look at the second query. Again, table B is mentioned in both the join conditions, and column key 1 from table B is used in the first join with table A, and column key 2 from table B is used in the second join with table C. So in this case, it would take two MapReduce jobs to perform the join operation. The first MapReduce job will perform the join operation on table A and B, and then the result will be joined with table C using the specified join condition. But wait a minute. We did not answer one important question. We still haven't learned how joins are represented or performed internally in MapReduce jobs generated by Hive. We're not going to look at how joins are performed behind the scenes in this lesson. We'll be looking into that in the optimizations chapter. So don't miss to check that out. So let's summarize what we learned in this lesson. We learned how to perform basic join operations in Hive, like inner, left, and right outer joins. We also saw the benefits of left semi-join and how we can work around performing an inequality join. Lastly, we looked at the number of MapReduce jobs it would take to perform joins with more than two tables. With that, let's wrap this lesson. See you in the next lesson.